Welcome back to Partial Fraction Decomposition, Calculus 2 with yours truly, Professor Rasky. And we are now at part 5 of this lecture. Hold on to your hairdo because this one is going to be intense. A lot of algebra. We're going to finally get into something called quadratic factors. So what's a quadratic factor? Well, x squared plus 4 is what we call an irreducible quadratic factor. It's not factorable over the set of integers. Now, if it had been a difference of squares, of course it would have been factorable. If that had been, say, x squared minus 4, sure, we could continue and say easily factored into linear factors. But because it's a sum of squares, can't factor it, okay? So don't forget that. Now, this other factor here, x squared minus x, that we can continue to factor. That's not an irreducible quadratic factor. If we factor out a common factor of x, the other factor is x minus 1. And these are two distinct linear factors. So this is going to be an intense problem because, as you see, when we're going to break this down using PFD, partial fraction decomposition, we're going to need 3 separate partial fractions, one for the x, one for the x minus 1, and then one for this irreducible quadratic, which the numerator, please notice, is not just a single constant. It's actually a linear factor. That's linear, cx plus d. We have 4 unknowns we're going to have to find in this problem, a, b, c, and d. So yeah, it's going to be pretty intense. A lot of algebra. So we can't even do the calculus until we've done a lot of algebra. So we're going to get the basic equation like we did on all the previous examples. So we're going to start by taking a look at this integrand where the denominator is fully factored, and my computer is so slow I don't know what to do. So if I multiply both sides of this equation by the LCD, which happens to be this huge product, this will clear out, this will clear out all of the fractions in this big old equation and get to the basic equation. And that's what we're going to focus on in order to help us get these unknowns of a, b, c, and d. That's our job. So after I multiply both sides by the LCD and simplify and reduce, I will get this basic equation. 2x cubed minus 4x minus 8, and that's going to equal a times the quantity x minus 1 times the quantity x squared plus 4 plus b times x squared plus 4 plus the quantity cx plus d times x minus 1. There's the basic equation. Now, we can substitute a couple of values for x that will help us get a couple of the unknowns, specifically a and b. But unfortunately, after that, we'll have run out of options of just easily substituting a value to get the unknowns, and we're going to have to go and dig deep into some other algebra resources here. But let's start off easy first. If we let x equal 0, the two big old terms in this big equation to the right, on the right side, will disappear. So let's do that first, and that'll help us get one of the unknowns, a. So if I substitute x equals 0 into this basic equation, what am I going to get? 2 times 0 cubed minus 4 times 0 minus 8 is equal to a times 0 minus 1 times 0 squared plus 4. Everything else disappears. So we have negative 8 is equal to a times negative 1 times 4. And so if I divide both sides by -4 and simplify, I'll get a is equal to 2. Good news, we now have one of our unknowns. Yay, success. So let's go ahead and substitute another value for x into my basic equation. So if I substitute x equals 1 into this big old basic equation, on the left I'll have 2 times 1 cubed minus 4 times 1 minus 8. What is that? 2 minus 4 is -2 minus 8. I think that's going to be, what? -10? And that's going to equal, on the right-hand side, this first term disappears because 1 minus 1 is 0. And then we'll have b times 1 squared plus 4. And then the cx plus d disappears because it's got that x minus 1 factor in it. So I'll have b times 1 times 5, and if I divide both sides by 5, I'll get b is equal to -2. Yay, success! I have another unknown. Okay, now what about the c and d? I've run out of options to substitute in that will kill off any terms. So what we're going to do is this technique where we're going to end up with 2 equations and 2 unknowns. So how do we do that? I'm going to pick 2 values of x I haven't used yet, preferably easy values. I'm going to do x equals -1, and then I'm going to also try x equals +2, separately, of course. And then using the fact that a is 2 and b is -2, we'll get 2 equations where the 2 unknowns are c and d, and we'll be able to wrap it up and get c and d and then finish the problem. Okay? So let's go ahead and let x equal -1, and then remind ourselves that a is now 2 and b is now -2, because we got those guys already. So on the left-hand side, when we substitute x equals -1, I'll have 2 times -1 cubed minus 4 times -1 minus 8. And that's equal to a, but we already know what a is. It's 2 times x minus 1, so -1 minus 1, and I'm just looking at this basic equation up here. And then -1 squared is +1, so I'm just going to go ahead and go 1 plus 4 plus b, but b is -2, times x, but remember x, we're substituting x equals -1, and then 1 plus 4 is what we're going to have there, and then plus, and I'm running out of room, so I'll go to the next line, cx, but that's c times -1 plus d times x, x is -1, and then the last factor there is x minus 1, -1 minus 1. Okay, this is a big mess. You got to clean this up with all the arithmetic here. So on the left-hand side, what do we have here? We have 2 times -1 cubed, but that's 2 times -1, and then minus 4 times -1, so we have minus -4 minus 8. So what does that give us on the left? So we have -2 plus 4 minus 8. So that looks like we have 2 minus 8, which is -6. So on the left we have -6. That's equal to, on the right hand side we have 2 times -2 times 1 plus 4 is 5. So that looks like we have -4 times 5, or -20. Okay, so far so good. Plus, and I've got to look here. This is the next term we're working on here. -2 times -1 is +2 times 5. So that's 10. So we have -20 plus 10. -20 plus 10, I believe, is -10. Okay, so far so good. Plus, now over here we have -1 times -2, but that's a +2. And so what I'm going to do is I'm going to distribute this +2 over the sum. So I'll have 2 times -1 times c, but that's -2c plus 2 times d. So I have -2c plus 2d. So this is the equation I have so far. If we clean it up just a little bit by adding 10 to both sides of the equation, like so, I'll have -6 plus 10 on the left, that's 4, is equal to -2c plus 2d. And we could leave it like that, or we could clean it up by reducing it just a little bit. How about if I multiply both sides of the equation by a half and then reduce, and I'll get 2 is equal to, after distributing the half, I'll get negative c plus d. So I'm going to save that equation for later. Let me put a box around it so I don't forget it. Save for later. I told you this was going to be intense. So now I'm going to substitute, going back to the original basic equation, x is equal to 2, and keep in mind that a is 2 and b is negative 2, and I'll get another equation with c and d being unknowns. So I'm going to need more room because I'm running out of room. Wow, who knew this was going to take so much space? So now back to the basic equation, only this time you're going to let x equal 2 and remind myself that a is still 2 and b is still negative 2, because I got those guys already. So in the basic equation, we're going to have 2 times x cubed, but that's 2 times 2 cubed, minus 4 times x, 4 times 2, minus 8. That's the left-hand side. On the right-hand side, we're going to have a, but a is 2, and then we're going to have 2 minus 1 times 2 squared plus 4, plus b, but remember we got b, he's negative 2, times x, but x is 2, times 2 squared plus 4, plus cx plus d, but that's c times 2 plus d, times x, but x is 2, and then 2 minus 1. Okay? So let's clean this up with our arithmetic. So on the left-hand side, we have 2 times 2 cubed, 2 times 8, minus 8, minus 8. That's 16 minus 16. Ah, that's 0. So 0 on the left. Oh, that was easy. And that's equal to, the first term, we're going to have 2 times 1, 2 squared plus 4 is 8, plus the second term here, negative 2 times 2 is negative 4, 2 squared plus 8 is 2 squared plus 4 is 8. And then over here, let's see, we have 2 times 2 minus 1. That's 2 times 1, which is 2. And let's distribute the 2. So we'll have 2 times 2c, which is 4c plus 2d. I hope I'm not driving you too nuts, because I'm driving myself nuts. Okay. So we have 0 equals 16 minus negative 4 times 8. So that's minus, what am I doing here? Minus 4 times 8, not adding here. Minus 32 plus 4c plus 2d. Okay, we're getting somewhere. Good Lord. Okay, now 16 minus 32 is negative 16. So we have 0 equals negative 16 plus 4c plus 2d. Yikes. How about if we add 16 to both sides? And so we have 16 is equal to 4c plus 2d. And we could leave it. I'm going to reduce, so I'm going to multiply both sides by a half again and get a little bit more simple of an equation. We'll get 8 is equal to 2c plus d. Whew. Okay, let me put a box around that. So what are we doing? Boy, we're just burning up the time here. What we have now is a linear system of equations, and I'm hoping that back in an algebra class from long ago, you learned how to solve one of these linear systems. Remember that? So, how do you solve this system? Well, there's a couple ways, but one way, what I'm going to do here is I'm going to subtract the bottom equation from the top equation and eliminate d. So I have negative c minus 2c, so that gives me negative 3c, but then d minus d is 0, the d goes away, and then 2 minus 8, that's negative 6. And so, hey, I can get c. If I divide both sides by negative 3, I'll get c is equal to 2. And then if I substitute that into either one of the equations, so here if I substitute it into that first equation we have negative 2 plus d is equal to 2, and if I add 2 to both sides, I'll have d is equal to 4. So good news, I got the 2 other unknowns. Whew. So what does that mean? That means we can finally go back to our original decomposition, which is way back here. Where is it? And we can put in our unknowns of A, B, C, and D, and finally get back to the calculus, and that is integration. So what we're going to do here is we've got A over x, so that was 2 over x, and then b was negative 2, so I'll put a minus there, b over x minus 1, plus, now here's the hard part, we're going to have cx plus d all over that irreducible quadratic x squared plus 4. Okay, now you're going to have to use some techniques that we learned some time ago, and you might have learned it in Calc 1. You're going to have to split this up into 2 separate fractions before you integrate that last term. So the first 2 terms you're just going to easily integrate with the log rule, and the second term needs u sub. But this one, first term is simply 2 ln absolute value of x. Second term minus 2 ln absolute value of x minus 1, plus you're going to have to integrate, and I'm splitting this up into 2 separate integration problems, 2x over x squared plus 4 dx, plus the other term 4 over x squared plus 4 dx. 2 completely different strategies. Log rule with some u sub. U is x squared plus 4. du is 2x dx. So this integral already looks like 1 over u du, so that antiderivative will simply be ln, and I don't even need to put absolute value around the x squared plus 4. It's guaranteed to be positive. This last term, you're going to need to use the arctan rule for integration. U is x, du is dx, and a is 2. And you also have this 4 here, so I'll keep that in the mix. You'll have 4 multiplied by 1 over a, 1/2, times arctan of u over a. So that's x over 2 plus c. So your final answer, don't forget these first 2 terms, is pretty amazing. And if you want, you can condense those 2 logs as usual. So you're going to have these 2 logarithms, then this third logarithm, and then reduce this here. You'll have 2 arctan x over 2 plus c. And that concludes that example. Thanks for watching, and we'll see you on the next installment of Partial Fraction Decomp. Bye for now.